Assalamualaikum and hi. My name is Nuralia Mirabitus Kanain. My matric number is AA190099. So I'm going to explain about lab, which is mechanical heat pump. A heat pump is a device that absorbs heat from waste source or surroundings to produce valuable heat on a higher temperature level than that of the heat source. The fundamental idea of a heat pump is that heat is absorbed by a medium which releases the heat at a higher temperature after a physical or chemical transformation. Heat pump technology has attracted increasing attention as one of the most promising technologies to save energy. Generally, there are three types of heat pump system, which is the first one is closed cycle vapor compression heat pumps for electric and engine driven, and the second one is heat transformers, which is a type of absorption heat pump, and the last one is mechanical vapor recompression operating heat pumps. Most of the heat pumps operate on the principle of the vapor compression cycle. In this cycle, the circulating substance is physically separated from the heat source and heat delivery and is cycling in a closed stream.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulfikar bin Muhammad Fazil and my matric number is AA190152. Okay, so now I will talk about the objective of mechanical heat pump experiment. Okay, so the first one is to determine the power input, heat output and coefficient of performance of a vapor compression heat pump system. Next is to produce the performance of heat pump over a range of source and delivery temperatures. Okay, that's all for me.
So, I'm going to explain about the next experimental, which is experimental procedures. Okay, the first one, to make this experiment, we need to perform the general startup procedures. Then we need to adjust the cooling water flow rate to 40%, which is 4.0 LPM. And then we need to allow the system to run for 50 minutes. After that, we record all necessary readings into the experimental datasheet. Then after we have do all the things, we need to repeat the experiment with reducing water flow rate so that the cooling water outlet temperature increase by about 3 degrees Celsius. And the second last is repeat similar steps until the compressor delivery pressure reach around 14.0 bar. And the last one is the experiment may be repeated at a different ambient temperature. Next, I'm going to explain about the evaluation and analysis data. So, there is 3 tests in this data, in this experiment, which is for test 1, cooling water flow rate at 10%. So, we can see that for the test 1 is 10% and the second test is 20% and the third test is 30%, which is for the LPM is test 1 is 1, test 2 is 2 and test 3 is 3. Cooling water inlet temperature for the test 1 is 44.6, for the test 2 is 31.2 and for the test 3 is 31.3. And cooling water outlet temperature for the test 1 is 50 degrees Celsius, for the test 2 is 46.8 degrees Celsius and for test 3 is 40.5 degrees Celsius. And compressor power input for test 1 is 389 watt, for test 2 is 370 watt and for test 3 is 349 watt. And heat output for test 1 is 376.2 watt and for the test 2 is 2173.6 watt and the test 3 is 1922.8 watt. And the last one is COP is for test 1 is 0.967, for test 2 is 5.875, and for the test 3 is 5.509. So that's all from me. So that's all from our group for this experiment. Thank you.